Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. All right, lesson 12, Ferris wheels, using trigonometric functions to model cyclical behavior. Classwork opening exercise says, Ernesto thinks that this is the graph of f of x equals 4 sine times x minus pi over 2. Danielle thinks it's the graph of f of x equals 4 cosine x. Who is correct and why? Okay, so here we go. First of all, I'm going to write f of x equals a sine omega minus h, forgot my x, f sine omega times x minus h plus k. Okay, what is A? A is the amplitude. Amplitude, the absolute value of A. In this one, the amplitude equals 4. The omega equals, there's nothing there, so it's 1. H of x, H is, hang on, time out. Let's do this right. Frequency is the absolute value of omega over 2 pi. Period is the inverse, 2 pi over the absolute value of omega. Okay. Phase shift is h. Vertical shift is k, and the midline is y equals k. So therefore, we get y equals something. All right, so I'm looking at Ernesto's graph first. So for starters, A is 4. There is no k. Let's start with k. K equals 0. Therefore, the equation of the midline is y equals 0. So it didn't change. So if I draw that midline, it's the x-axis. Okay, so there's the midline. So it's not shifted up or down. What is h in this situation? H is pi over 2. That means we're going to take, if this is the sine function, we're going to take the sine function. What does the sine function look like? Let's graph that first. So the sine function starts at 0 and ends at 2 pi. We'll just do one period. At pi over 2, or pi, it's at the middle. So it's back to 0. Its maximum is 1 at pi over 2, which would be right here. And its minimum is at 3 pi over 2. So this is the parent function sine right here. So what we want to try to determine is which of these two graphs is this. Okay, so first thing I would do is start with my starting point. If this is going to get shifted by a direction to the right of pi over 2, well, pi over 2 is right here. So that would put us right here. So I will do the graph of f of this in blue. So it starts there. Its period is 1 over 2 pi is the frequency, and its period is 2 pi because omega is 1. So this is going to be the same period of 2 pi. So if it's starting at pi over 2, it's going to be pi over 2 greater than 2 pi at the finish, which is going to be right here. Okay, so far so good. We're on the graph with those 2 points. So the middle's halfway in between, which is here. And once again, there we are. A is positive, omega is positive, so it's not a reflection. Okay, so then we're going to stretch it vertically by a factor of 4. So that's going to bring our maximum up to 4 instead of 1. So our maximum is going to be 4, which is right here. And our minimum is going to be -4. Okay, so this is the graph of f of x equals 4 sine x minus pi over 2. Now, before I continue, I'm going to graph 4 cosine. So the cosine function starts at 1 and it ends at 1, and its middle is its minimum, which is at pi, -1. So the cosine function comes down like this and comes up like this. That's 1 period of cosine. So if this were 4 cosine, then we would have stretched this up to 4. Let me do this up here. 1, 2, 3, 4 would put me here and here. And stretching it down 4 would put me here. And I went down too far here, by the way. So let me erase this. This was incorrect. All right. So let me actually do an undo so I'm not erasing everything else. Okay, right here. I need to move this. I put that at 2. That should be at 1. So now my cosine function goes from there through that 0 down to a minimum, back up, and like so. A little bit better curve here, if you will. Okay. It's a little bit better, but not much. All right, so 4 cosine would just stretch it up 4. 1, 2, 3, 4 would put me here. And from instead of 1 down to -4 would put me here, and the max back up to 4. So this would be, let me do it in green. This would be the 4 cos x. Okay. So obviously Ernesto is correct. And if we wanted to put this into words, we would say all this. We'd say Ernesto's correct. For the function y equals a sine omega x minus h plus k, Ernesto's solution would have a equals 4, omega equal 1, h equals pi over 2, and k equals 0, which I have all up over here. The graph shown has an amplitude of 4 and a period of 2 pi. Compared to the graph of the sine function, this graph is not translated vertically, making k equal to 0. The graph is a horizontal translation of the graph of the sine function to the right, pi over 2 units. Meanwhile, for y equals a cosine omega x minus h plus k, Danielle's solution would have a equals 4 omega 1, h 0, and k 0. However, the function f of x equals 4 cos x has a maximum point at 0, 4, which I graphed with this red dot right here. And this graph has a minimum point when x equals 0. So it's saying this has a minimum at x equals 0 instead of a maximum. To be correct, Danielle's function would have to be f of x equals -4 cosine of x. The dotted graph below is the graph of f of x equals 4 cosine x. The dotted graph below. Okay, so this would be 4 cos x. So notice the difference. The dotted line, which I graphed in green, just 1 period. All righty. Okay, page 2 brings us to exploratory challenge exercises 1 through 5. So a carnival has a Ferris wheel that is 50 feet in diameter with the 12 passenger cars. Okay, so if you have 12 passenger cars, 360 divided by 12 is 30 degrees. So every passenger car is 30 degrees apart. So car number 1 being at 9 o'clock, this is 30, 60, 90. 120, 150, 180, 210, 240, 270, 300, 330, 360, and we're back to the beginning. So they're each 30 degrees apart. All right, when viewed from the side or passenger's board, the Ferris wheel rotates counterclockwise. So the Ferris wheel is going this way. So car 1, then car 2 is going to come up to where car 1 is, and so on. And it makes 2 turns, 2 full turns every minute. So a half a turn or 1 full turn every 30 seconds. Riders board the Ferris wheel from a platform that is 15 feet above the ground. We will use what we have learned about periodic functions to model the position of the passenger cars from different mathematical perspectives. We will use the points on the circle in the diagram on the right to represent the position of the cars on the wheel. So number 1 says, for exercise 1, for this exercise, we will consider the height of the passenger car to be the vertical displacement from the horizontal line through the center. Height of the passenger car, vertical displacement. Okay, so this would be 0. And as we're going around, vertical displacement is going to be how far up. So this is going to be 25 feet here, and a third of 25 feet, 2/3 of 25 feet, and so on. No, not necessarily. This is closer than that. So anyhow, vertical displacement. All right. And the co-height of the passenger car to be horizontal displacement from the vertical line through the center of the wheel. Horizontal displacement is co-height. Well, co-height is cosine, and height is sine. So co-height going this way, this point right here, for example, would be the point over 25 feet and up 0 feet. This point over here would be over 0, up 25. This point, car 7, would be negative 25, comma, 0. And this point right here, number 4, would be over 0, down 25 feet. So there's those 4, which is pi over 2, pi, 3 pi over 2, and 2 pi are 0. So now it says let theta equal 0. Represent the position of car 1 in the diagram above. So theta equals 0 represents the position of this car right here. So at 0, we are at a height of 25. Sketch the graph of the co-height and the height of the car 1 as functions of theta, the number of radians through which the car has rotated. Okay, so I have the graph here already, and I'll just discuss where it came from. So the co-height, as I said, is the cosine function. So car 1, we're at 25, 0. We're graphing the cosine. So at car times 0, we're at 25 feet above there. So right here, we're to the right 25, co-height, not above, to the right. So we're to the right 25. Then at pi over 2, we're over 0. So now what I'm doing in the blue is graphing these. So at pi over 2, let me put these. This is pi over 2. We are at 0. At pi, which is right here, we're at negative 25. At 3 pi over 2, which is right here, cosine is 0. And then finally back to 0 or 2 pi, 0 comma 2 pi, same point, we are at 25. And it repeats. 5 pi over 2 would be here, back to 0. And 6 pi over 2 or 3 pi would be right here, which is down here. Okay, so that's how we graph that. And then if we graph the height of the function, that's our y. Our height is y. So at 0, car 0 is right here, times 0, we're starting in car 1, my height is 0. At pi over 2, my height is 25. At pi, my height is 0. And at 3 pi over 2, I'm at negative 25 with respect to where we started. And then at 2 pi, we're back to where we started. And 5 pi over 2 is the same as pi over 2. We're back up at 25 feet. So there are the graphs of the height and the co-height of this Ferris wheel rotating. Okay, part B says, what is the amplitude? What is the amplitude, the absolute value of A, of the height and the co-height function of this Ferris wheel? Well, our midline is the x-axis on both. The maximum of this right here is 25. The minimum is negative 25. So the amplitude, the absolute value of A, equals the absolute value of 25. Okay, that's the amplitude. So I would say the absolute value of A equals the absolute value of 25, which is 25. All right, so that is the co-height of, or that's the amplitude of the co-height, but it is also the amplitude of the height, because this also has a maximum of 25 and a minimum of negative 25 with a midline at 0. So they both are the same. The amplitude is 25. Okay, part C on page 2 says to let x of theta represent the co-height of the function, co-height function after a rotation by theta radians, and let y of theta represent the height function after rotation by theta radians. Write function x for the co-height and y for the height in terms of theta. So here is my right triangle where theta is the central angle of that Ferris wheel circle. And I just plugged in opposite with respect to theta, adjacent, and the radius. But now I'm going to put values in. So it said x is the co-height. So I'll put an x here. Y is the height. So I'll put a y here. And the radius of our Ferris wheel was 25 feet. So there is our right triangle set up with respect to x and y. So if I wanted to find theta, if I wanted to find, for example, it says write functions for co-height and y for height in terms of theta, then I would say x. So if I say the sine of theta equals y opposite over the hypotenuse, and I simplify this, then I multiply both sides by 25, that will give me y equals 25 times the sine of theta. Okay, so in other words, instead of just saying y, I could say y of theta equals 25 sine theta. Doing the same for the cosine, if I said the cosine of theta equals x with respect to theta divided by 25, let's do it that way. And I multiply both sides by 25, 25 would come over here. This would yield x of theta would equal 25 times the cosine of theta. Okay, so there's just a quick shortcut. All you do is take the radius times the cosine for this side, radius times the sine for this side. D, graph the function x and y from part C on a graphing calculator set to parametric mode. Use viewing window negative 48 to 48 by negative 30 to 30 and sketch that graph below. Okay, so graphing calculator. Clear that, go to y equals, clear, clear. So graph the function x and y from part C in the graphing calculator. Set to parametric mode. So I go to mode. Function parametric is right here. So you come down to function, switch over to pair, hit enter, window, negative 48, x min negative 48, x max 48 by negative 30 to 30. Negative 30 to positive 30. Okay, negative 48 to 48, negative 30 to 30. Parametric, go to y equals, and plug in our values here. So when I do that, I want to put 25 sine t and 25 cosine x or t or theta or n using that button. And then when I graph it, it graphed a circle. There is our Ferris wheel. Okay, so then it says to sketch that function. Okay, so the graph on the left was my screenshot from my TI-84 Plus, and this is what it would look like if I had the color edition, the CE. Okay, so part E says, why did we choose the symbol X and Y to represent the coheight and height functions? Okay, the coheight function measures the horizontal position of the passenger car that we typically name X. The height function measures the vertical position of the passenger car, which we typically name Y. It makes sense to use X as the name of the function that describes horizontal movement and Y as the name of the function that describes vertical movement. Part F says to evaluate X of 0 and Y of 0 and explain their meaning in the context of the Ferris wheel. All right, so using the equation from part C, X of 0 equals 25 cosine 0 equals 25, and Y of 0 equals 25 sine of 0 equals 0. Thus, when the wheel has not yet rotated, that is, rotated through 0 radians, the coheight of the car is 25, and the height of the car is 0. This means that the car is at the 3 o'clock position. G says to evaluate X of pi over 2 and Y of pi over 2 and explain their meaning of the context of the Ferris wheel. Okay, so using the equations from part C, X of pi over 2 is 25 times the cosine of pi over 2, and cosine of pi over 2 is 0, so 25 times 0 is 0. And Y of pi over 2 is 25 times the sine of pi over 2. The sine of pi over 2 is 1. 25 times 1 is 25. Thus, when the wheel has rotated through pi over 2 radians, that is, rotated through a quarter turn, the coheight of the car is 0 and the height of the car is 25. This means that the car is at the top of the wheel. All right, page 4, number 2, the model we created in exercise 1 measures the height of car 1. Okay, car 1 is right here. Above the horizontal line through the center of the wheel. We now want to alter this model so that it measures the height of car 1 above the ground. Before we were just doing it above car 4. If we measure the height of car 1 above the ground instead of above the horizontal line through the center here of the wheel, how will the function X and Y need to change? So in the first page, it told us that the Ferris wheel is 15 feet off the ground. So if this is a distance of 25 feet and this is 15 feet, then this distance total is 40 feet. So that's how we have to change it. So the coheight function X will not change. Okay, we're still going to the right 25 from the center of the wheel to get over here, so that doesn't change. But the height function Y will need to have a constant added to it since car 1 starts 40 feet above the ground. Okay, so we have to add that to it. Part B says, let theta equal 0. Represent the position of car 1. Okay, so if theta is 0, here's what that says. Sketch the graph of the coheight and height of the car 1 as functions of the number of radians through which the car has rotated theta. Okay, so I'm going to do as I did in the first page. I'm just going to show you the graphs and notice what happened here. The cosine function, in other words, the co-height function, did not change as it said up here. We are still going 25 feet to the right. We're still going 25 feet up from this line and 25 feet left and 25 feet down. So, or I'm sorry, the co-height is this way, left, right. So we're going a maximum of 25 feet to the right and a minimum of negative 25 feet to the left. So here's our maximum, here's our minimum of 25 feet, okay? Max and min's back to 0. So we're going from 25 down to 0, back up to, or down to negative 25 and then back. And that's all it keeps doing. So co-height did not change, but notice the change in the height function or sine. So instead of now starting at 0, we are starting 40 feet above the ground. So what that has done is given us a midline of 40 feet. And let me do that in green. So now our midline is right here. So it shifted it up 40 feet. And then the maximum of 25 above that would bring us to 65. And 25 feet below 40 brings us to 15, which is the distance car 4 is right now from the ground. So that's the change we had to make with respect to the height. C says, how are the graphs from part B related to the graphs from exercise 1A? Okay, so the co-height graphs are the same. The height graph from part B is the height graph from exercise 1A, translated 40 units upward. So remember, if it's shifted up 40 units, that is our K in the function f of x equals amplitude times sine omega x minus h plus k. The 40 is our K, shifting the whole function up 40 units. Okay, page 5, part D, continuing on this, it says, from this perspective, find the equations for the function x and y that model the position of car 1 with respect to the number of radians the car has rotated. So the cosine has not changed. The co-height has not changed. So if we say x of theta, that's still going to equal 25 times the cosine of theta. Okay, but y, on the other hand, has changed. Y sub theta is now going to equal 25 cosine or 25 sine theta. But as in this diagram over here states, this distance here is your 25 sine theta, but it's elevated a distance of the radius of the Ferris wheel plus 15 feet that the Ferris wheel is above the ground. So this totals 40. So we're going to shift that up 40. So there's the equation with respect to x and y. Part E says, change the viewing window on your calculator to negative 60, 60, negative 5 to 70, and graph the function x and y together. So now I want to change the viewing and graph these. So I'll go back to my calculator, go to my window, and now I want the x minimum to be negative 60, and the x maximum to be 60. And we want the y minimum to be negative 5 and the y maximum to be 70. And then we're going to go to y equals, and we're going to just put plus 40 at the end of the sign and graph. X min negative 60 to 60 by negative 5 to 70. Okay. Okay, so I did this backwards. So if you see this, it's x sub 1, y sub 1. I've got them backwards. So x sub 1 should be cosine. When they were the same, it didn't matter, but now it does. And I don't want to add 40 to my cosine. And then this one needs to be, since it's y sub 1, that has to be sine. And I want to add 40. So now when I graph it, there we go. That makes more sense. So there it is. There's our Ferris wheel off the ground 15 feet. So then it says to sketch that graph. Okay, so there's what it would look like taken from the TI 84 Plus, and this one from the CE edition. All right, F, evaluate X of 0 and Y of 0 and explain their meaning in context of the Ferris wheel. Okay, so using the equations from part C, X of 0 equals 25 cos 0, and the cosine of 0 is 1, so therefore it equals 25 times 1 or 25. And y of 0 equals 25 sine 0 plus 40. Sine of 0 is 0. 0 times 25 is still 0, but 0 plus 40 is 40. Thus, when the wheel has not yet rotated, that is, rotated through 0 radians, the co-height of the car is 25 and the height is 40. This means that the car is at the 3 o'clock position. All right, so now part G says to evaluate x of pi over 2 and y of pi over 2 and explain their meaning in the context of the Ferris wheel. So again, we plug those values into the functions, and the cosine of pi over 2 is 0, so 25 times 0 is 0. And the sine of pi over 2 is 1, so 25 times 1 is 1 plus, or 25 times 1 is 25, plus 40 is 65. Thus, when the wheel has rotated through pi over 2 radians, that is rotated through a quarter turn, the co-height of the car is 0 and the height is 65. This means the car is at the top of the wheel or at 12 o'clock. All right, page 6 brings us to number 3. It says, in reality, no one boards a Ferris wheel halfway up. Passengers board at the bottom of the wheel. To truly model the motion of the Ferris wheel, we need to start with passengers on the bottom of the wheel. Refer to the diagram below. So now we've rotated it so that car number 1 is down at 6 o'clock, 15 feet off the ground. And remember, there's a 15-foot platform so that they can board. And they're boarding down at 6 o'clock. Okay. Part A says, let's scroll up here. Part A says to let theta equals 0. Represent the position of car 1 at the bottom of the wheel in the diagram above. Sketch the graph of the height and co-height of car 1 as a function of theta. So before I graph that, I'm just going to label these locations now. Now we're starting right here, and cosine x is 0 and y is 15. Over here, cosine is 25, or the co-height is 25, and the height is 25 plus 15, or 40. At the top here, and by the way, this is 3 pi over 2, and this is 0 or 2 pi, and this is, number 7 is pi over 2, and number 4 is pi. Now pi over 2, let me give myself a little room here, is over 0 and up 25, 50, 65. So at the top, we're 65 feet off the ground. 50-foot diameter wheel, 15 feet off the ground. And then over at pi, we're at negative 25, comma, 40. So there are the 4 locations of cars 1, 4, 7, and 10 at the starting, when 1 is at the starting point. Okay, so now we're going to graph that, and here's what it would look like. So at 0, now we're down here, cosine is 0. And then when we rotate to here, that's going to be a distance of pi over 2. And now our cosine is at 25. And we're going to rotate counterclockwise up to 7, and our cosine is 0 at pi over 2. But that's a distance. If this now, we need to relabel these. So let me change these, because we're not starting over here where we were. We're now starting down here. So this is 0, or 2 pi. This will be pi over 2. This is pi, and this is 3 pi over 2. And back to 2 pi. Okay? So pi over 2 is here, and that's why we're up at 25. Pi, cosine is 0, right there. Continuing around to 3 pi over 2, cosine is negative 25. Going back to 2 pi, we're back to the starting point. That is cosine, the co-height is 0. And then this would be 5 pi over 2, and we're back to 25. And if we continue, then we're back up here down to 0 again. So there is the cosine function graphed. So what did it just do? Well, it shifted to the right pi over 2, which is a quarter rotation from here to here. The sine function, on the other hand, when we are here, we are 15 feet off the ground. That's negative, or that's 15 feet off the ground. I'm sorry, positive 15, which is right there. As we're rotating counterclockwise, we're going this way. At pi over 2, we are at 40. Here's pi over 2. Here's 40. At pi, a half a rotation, we're at the top of the Ferris wheel, 65. At pi, we are at 65. Continuing around to 3 pi over 2, we're at 40 again, which is here. And then continuing back around, we're now back down at the bottom, 2 pi. Continuing back on our second rotation would put us back, 5 pi over 2 would put us at 40, and 6 pi over 2 or 3 pi would put us back at the top at 65 feet. Okay, so those are the two graphs. Part B says, how are the graphs from part A related to the graphs from exercise 2B? So here's part A. Let's go back to 2B. Here's 2B. So the cosine got shifted to the, well, let's see. Let's copy these and bring them over, just so we aren't trying to go back and forth repeatedly. All right, so what this question is saying, part B is comparing these graphs now. How are the graphs from part A, right here, related to the graphs from exercise 2B, which are right here? So from here, this function got shifted to the right pi over 2, and this function got shifted to the right of pi over 2. Nothing else changed. So that's what we would say. The graphs from part A and the graphs from exercise 2B translated horizontally pi over 2 units to the right. All right, page 7, part C. From this perspective, find the equations for the function x and y that model the position of car 1 with respect to the number of radians the car has rotated. So before I get into that, remember the equation. It is f of x equals a sine omega x minus h plus k. All right. Well, what changed in this one? So if I go back, what happened? Translated horizontally pi over 2. Well, that shouldn't be purple. That should be blue. Okay. So that's a horizontal or a phase shift of pi over 2 to the right, which means it's going to be x minus pi over 2 in my equation. So I'm going to take this equation, and right here, I'm going to have a pi over 2. So we get x of theta equals 25 cosine theta minus pi over 2, because it did get stretched up 25 feet, right? That's always been 25 sine theta, 25 cosine theta. And the y portion of this is going to be shifted to the right pi over 2 as well, but it's also going to be shifted up 40. So cosine didn't change. The co-height did not get moved up 40, but the sine, the height did. So now it says to graph the functions x and y from part C together on the graphing calculator. So I go into my graphing calculator and I'm going to go to y equals, and now I'm going to change this. So it's going to be x is going to be 25 cosine theta, or t in this case, minus pi divided by 2. Okay, so we're going to put that in our calculator. Let me put parentheses around that. Okay, and sine is going to be, oh, hang on, let me just clear this and start it over. So it's going to be 25 cosine theta, or t in this case, minus pi over 2 and 25 sine t minus pi divided by 2 plus 40. Okay, so there it is graphed. So it says graph the function x and y from part C together on the graphing calculator. Sketch the graph. Show how is this graph different from the one from exercise 2E. Okay, so here is what we would have. Although the finished graph looks exactly like the graph from exercise 2E, this one starts drawing from the bottom of the circle as opposed to drawing from the 3 o'clock position. Okay, so basically what they're saying is, if I go to graph, or y equals, and graph this, it started at the bottom and just looped around. Whereas if I graph the other one, it was starting at 3 o'clock and going around. So if you watch that, then it started here and it went around like so. So part E says to evaluate x of 0 and y of 0 and explain their meaning in the context of the Ferris wheel. So what we're doing is we're putting a 0 in here for theta. So the cosine of negative pi over 2 would be here, which is 0, times 25, which is 0. And the sine of negative pi over 2 is right here. And that's what they're asking here. So using the equations from this part, then the cosine, 25 cosine 0 minus pi over 2 will equal 0. And y of 0 is 25 sine of 0 minus 2 pi, which in this case would be 0 minus pi over 2. And the sine of pi over 2, negative pi over 2 is 0. So 25 times 0, or 1, I mean. 25 times, no, it's negative 1. It's down 1, I'm sorry. Negative 1. So 25 times negative 1 is negative 25 plus 40 is 15. Thus, when the wheel has not yet rotated, that is, rotated through 0 radians, the co-height of the car is 0 and the height is 15. This means that the car is at the bottom of the wheel. Okay, part F, evaluate x of pi over 2 and y of pi over 2. So if I put pi over 2 in here, pi over 2 minus pi over 2 is 0. Cosine of 0 is 1, so I should get 25 for x. And if I plug in pi over 2 here, I get 0. Sine of 0 is 0, so 25 plus 0 plus 40 will give me 40. Okay, and so here we have it. 25 times the cosine of 0, which is 1, is 25. Cosine, or 25 times 1 is 25. And pi over 2 minus pi over 2 is 0. 25 times 0 is 0 plus 40 is 40. Thus, when the wheel has rotated through pi over 2 radians, which would put us at 3 o'clock, a quarter turn. The co-height of the car is 25 and the height is 40. This means that the car is at the 3 o'clock position. All right, page 8, number 4 says, finally, it's not very useful to track the position of Ferris wheel as a function of how much it has rotated. It would make more sense to keep track of the Ferris wheel as a function of time. Recall that the Ferris wheel completes 2 full turns per minute. So A says, let theta equal 0 represent the position of car 1, 6 o'clock at the bottom of the wheel. Sketch the graphs of the co-heights and the height of the car as a function of time. Okay, so let's discuss this. Here's the graphs. So we're starting here. Time 0. Co-height is 0. Co-height's your left-right direction from center. We're at 0 at time 0. This thing rotates 2 rotations every minute. So 1 full rotation is 30 seconds. A half a rotation is 15 seconds. A quarter rotation is 7.5 seconds. So as you can see, 1 full rotation all the way to the top, back to 0, all the way down to the minimum, and back to our starting point is 30 seconds. So we're starting here. This is 7.5 seconds. So at 7.5 seconds, we are at this point right here, 25. So after 7.5 seconds, our co-height is here, 25. Then it decreases until our co-height gets back to 0 at 15 seconds. That's here. That's a quarter of a minute, 15 seconds. 3/4 of a minute, or 22.5 seconds. Okay, I'm just finished filling this in. This is 30 seconds. At 22.5 seconds, we're 3/4 of the way around. We're at -25 right here. And then going back up to 30 seconds or a half a minute, we're back at the beginning where our co-height, left-right distance, is 0. And that repeats every time you rotate. So there is the graph of the function. So function co-height. So the height function, we are starting at 15 feet at time 0. We're 15 feet above the ground when we get on that platform and get in that first car. We are at 15 feet off the ground. We have not moved at 0 seconds. 7.5 seconds later, or a quarter of a minute, we are now up 25 feet from that 15 or 40, which is right here. And that right there would be a quarter of a minute. Actually, not a quarter of a minute, an eighth of a minute, or a quarter of a rotation, 7.5 seconds, we're at 40 feet. Okay. And then at 15 seconds, we're at the top, which is 25, 50, 65 feet. Here's 65. Then we start to come back down, and 7.5 seconds later, we're back at 40 feet height. And we're continuing down towards the ground until we get to the bottom. In 30 seconds or a half a minute, we're at the minimum again. And then it repeats. 15 or 7.5 seconds later, we're at 40. 15 seconds, we're at the top. Another 7.5 seconds, we're back down to 40. Another 7.5 seconds is a full minute. We're back down at the platform at 15 feet, and it just keeps repeating. So there you have it. All right, now part B. The co-height and height functions from part A can be written in the form of, and there it is, x of t equals a cosine omega t minus h plus k, and y of t the same with sine. From the graphs in part A, identify the values of A for amplitude, omega, height, or H, phase shift, and K, vertical shift for each function X and Y. All right, so it says co-height and height functions from part A. So let me bring those over so we can look at them while we're doing this. Okay, so here we go. So I will do the co-height, which is my X here. So it's going to be X of t. X with respect to time is what that means. Equals, well, what is A? Here's my midline. My A is max 25, min negative 25. So that's going to be 25. Cosine omega, okay, omega is what's omega going to be? 4 pi. Yeah, 4 pi, because we're going to do 2 full rotations. So this is going to be, well, let's just list them first. So A is going to equal the absolute value of 25, which equals 25. Omega is going to equal 4 pi. H is going to equal a phase shift of pi over 2. No. We're talking time now. So this is 1 minute. This is 30 seconds. This is 15 seconds. So this is 7.5 seconds. So if I split this up like so, that's 1, 2, 3, 4, 5, 6, 7, 8. So the shift cosine is supposed to start at 1. Here it's at 0. And so that's the maximum right here. And that occurred at 1/8 of a minute. This is a quarter, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So H is 1/8. And K, in this case, it is not shifted up or down. K is 0. Okay, so now for this one, A is going to equal the absolute value of 25 again, because what am I going to do here? Here, I'll just help out by drawing my midline, and I'll use green. My midline is at 40. Okay, the midline's at 40. So omega, in this case, is also going to be 4 pi. The shift is going to equal, again, we're at 0 here. So H is 1/8. We moved it over 1/8 of a minute, or 7.5 seconds. But in this case, K was shifted up 40. Okay, so there's our values using the graphs from part A. All right, I haven't really explained where I got 4 pi from. I just kind of did it quickly. Remember that your period is equal to, we use omega and 2 pi. Okay, so the way you do this is, you know that the period is omega, absolute value of why is that your absolute value of omega over 2 pi? Okay, so how many rotations are we doing? We're doing 2. So if I multiply both sides by 2 pi, then I get the absolute value of omega equals 2 pi times 2, which equals 4 pi. So omega is 4 pi, and that's where this came from, okay? All right, part E, explain the meaning of the parameters for equations for x. Oh, I skipped C. So all this stuff is in my way, so let's get rid of it, delete. Let's move this over here so I can read this and move this over like so. Okay. Clean this up. Part C, write the equation x of t and y of t using the values. So now let me do x of t first. So x of t is going to equal our a times cosine of 4 pi parentheses x minus h plus k, which is plus 0. So there it is. All right. And one little error here. I'm not using x anymore. We're using t for time. So this should be t minus 1/8. All right. Y of t is going to equal the same amplitude of 25. Absolute value of 25 is 25 times the sine of our omega times t minus h plus k. So there's the two equations. Part D says in function mode, graph your function from part C. This is just my midline. Graph your function from part C on a graphing calculator for 0 to 2, t being between 0 and 2, and compare against your sketches in part A to confirm your equations. All right. Okay, so I open my calculator back up. So we're leaving pair and moving back to function. In function mode, graph your function from part C. So I go back and change my mode to function and graph these. So now I'm going to go to y equals, and I'm going to put 25 cosine 4 pi parentheses x or t minus 1/8. Enter. And then I'm going to, for y of t, I'm going to put 25 sine 4 pi parentheses x or t minus 1/8 plus 40 and graph it. Okay, one thing I forgot to do is change my t from 0 to 2, which is our x. Okay, so clear or quit. Here, let me just turn it off. Turn it back on. And I want to go into my window. And I want to graph t, or in this case, x, from 0 to 2. And now graph it. Okay, so notice it's cut off here. Let that finish. So our window, if I trace this, the maximum is 25. So I want my window to go from y min negative 25 to maximum 25. That's our A. And then now graph it. So there is x cosine 4 pi t minus an eighth. And this is x, or 25 sine 4 pi t minus 1/8 plus 40. So there's the two graphs. And it says to compare against your sketches in part A to confirm your equations. Okay, so here's what they would look like if we graph them separately. So the blue one is cosine and the green one is sine. Okay, part E says to explain the meaning of the parameters in your equation for x in terms of the Ferris wheel scenario. All right, so for the co-height function, we have a equals 25, omega equals 4 pi, h equals 1/8, and k equals 0. That's the blue graph on the left. The amplitude a is 25, which means that the difference between the largest and smallest value of the co-height is 50 feet. This is the diameter of the wheel. The period p is 2 pi over omega absolute value, which equals 1/2. And the frequency f is 1 over p, which equals 2. This means that the wheel rotates twice each minute. The phase shift is h equals 1/8. Each quarter revolution takes 1/8 of a minute, which is 12.5 seconds. No, it's not. That's a misprint. 12.5 times 8 is not 60. Okay, so if I go back to my calculator, 60 divided by 8 is 1/8 of a minute. That should be a 7. Okay, 1/8 of a minute, which is 7.5 seconds. Without this shift, our equations would start car 1 in the 3 o'clock position. We want to start it from the bottom of the wheel. The equation of the midline is y equals 0, which means that the co-height varies between -25 and 25 feet. So they're talking about this blue graph here. Okay. All right, page 10 brings us to part F, and it says to explain the meaning of the parameters of your equation for y in terms of the Ferris wheel scenario. Okay, so here they are. So there's the graph. For some reason, the graphing calculator didn't graph this correctly when I graphed it. So here's what it should look like. It wasn't shifting it up 40 units. The midline should be at 40, not 0. So even putting plus 40 in there did not shift it up for some reason. But this is what it should look like. And it says for the height function, we have a equals 25, omega equals 4 pi, h equals 1/8, and k equals 40. The amplitude is a equals 25, which means the difference between the largest and smallest values of the co-height is 50 feet. This is the diameter of the wheel. The period is p, which is 2 pi over absolute value of omega, which equals 1/2. And the frequency is f equals 1 over p, which equals 2. This means that the wheel rotates twice each minute. The phase shift is h, which equals 1/8. Each quarter revolution takes 1/8 of a minute, which is 7.5 seconds. I don't know why they have so many misprints in their book. Without this shift, our equations would start car 1 in 3 o'clock position. We want to start it from the bottom of the wheel. This equation of the midline is y equals 40, which means that the height varies between 15 and 65 feet. All right. So moving on to part 5, it says in parametric mode, graph the function x and y from exercise 3 using the calculator from t equals 0 to 1/2 and sketch the graph. So I turn my calculator back on and I go to y equals, actually I want to go to mode and I want to go back to parametric and I want to go to my window, my table set, and I want t to go from 0 to 0.5 and graph it. Something is wrong with my window. T min 0, T max a half, minimum 0, max 2, that's my X. Okay, let's change that from negative 25 to 25. Let's see what that does. Okay, I'm just seeing a little blip here. So let me see what's going on here. Okay, so I didn't have the right graphs. I had the old graphs in there. So now I have to change this. So X1, that is 25 cosine 4 pi parentheses T minus 1 divided by 8. Okay, and then the other one is 25 sine 4 pi parentheses T minus another parentheses 1/8, 2 parentheses plus 40 and graph. My window, they said to do 0. Let's go back here now. For T equals 0 to 1/2. So T min 0, T max 0.5. All right, graph. Okay, so after graphing that in parametric mode, it says, although the finished graphs look identical, the difference is that the graph has a different scale for the parameter t. So the line across the bottom is no longer x, it is t, and instead of going to 2 pi, it's going from 0 to 1/2. So instead of needing 0 to 2 pi for theta to complete the circle, we only need to specify a time from 0 to 1/2, since the wheel makes one complete turn in 1/2 of a minute. B says, what would the graph look like if you graph the function x and y from the exercise 3C for 0 to 1/4 and y? Okay, well, a quarter is just going to give us 1/2 of a turn. So 1/4 of a minute, 1/2 a minute is going to rotate 1 full rotation, and 1/4 of a minute or 15 seconds, it's only going to do 1/2 of a rotation. So it will look like this. So if we graphed x and y for 0, for t being between 0 and 1/4, the graph would only show the left half of the circle. I'd say the right half of the circle, but anyway. This is because it takes 1/4 minute for the car to travel from the bottom of the circle to the top. Okay, so I guess it'd be the left if we were behind here, but this looks like it's the right side of the circle to me. All right, so there you go. Okay, page 11 brings us to part C, and it says to evaluate x of 0 and y of 0 and explain their meaning in the context of the Ferris wheel. So it says, using the equation from part C, x of 0 is 25 cosine 0 minus pi over 2, which is cosine of negative pi over 2 is 0. So 25 times 0 is 0. And y of 0 is 25 sine 0 minus pi over 2 plus 40. Well, sine of negative pi over 2 is -1. So 25 times -1 is -25 plus 40 equals 15. Thus, when the wheel has not yet rotated, that is, rotated for 0 minutes, the co-height of the car is 0 and the height is 15. This means that the car is at the bottom of the wheel. Okay, so now it says to evaluate x of 1/8 and y of 1/8. So using the equation for part C, x of 1/8 would be 25 cosine 4 pi 1/8 minus pi over 2. Well, 4 pi of 1/8 is pi over 2, right? 4 pi over 8 is pi over 2. Pi over 2 minus pi over 2 is 0. Cosine of 0 is 1. 25 times 1 is 25. And y of 1/8 equals 25 sine of 4 pi over 1/8, which is pi over 2. So pi over 2 minus pi over 2 is 0. Sine of 0 is 1. So that's 25 times 1, which is 25, plus 40 equals 40. Is that right? No. Sine of pi over 2 is 0. Sine of 0 is 0, I'm sorry. Sine of 0 is 0. 0 times 25 is 0, plus 40 is 40. So thus, when the wheel has rotated for 1/8 of a minute, that is rotated roughly a quarter turn. Since the wheel rotates once every half a minute, the co-height of the car is 25 and the height is 40. This means that the car is at 3 o'clock position, and that happens after 7 1/4 or 7.5 seconds. Yeah, 7.5 seconds. Number 6, exercises 6 through 9. You're in car 1 and you see your best friend in car 3. How much higher than your friend are you when you reach the top? Okay, so there's 2 ways to do this. I'm in car 1, or you're in car 1, which is right here. Car 1. And you see your best friend in car 3. Your best friend is right here. How much higher than your friend are you when you reach the top? So if I rotate counterclockwise for 15 seconds, I am now here, car 7. You were 2 cars away. Your friend was 2 cars away. They are now here at 9. How high is this? That's what this question is asking. So this distance right here is 25 plus 15, or a total of 40 feet. This height up here is 65 feet. We're at the top. This is in between 65 and 40. So to calculate that, we would want to use the equation. So I brought it in. When you are at the top, your height is 65 feet and you have rotated through 180 degrees, which is pi radians. At that time, your friend in car 3 has rotated through 60 degrees less than you had, right? 2 cars away, 30 degrees per car. So car 3 has rotated 120 degrees, which is 2 pi over 3 radians. Using the height as a function of rotation from exercise 3, we know that the height of the car of 3 is y of 2 pi over 3, which is 25 sine 2 pi over 3 minus pi over 2 plus 40. Well, 2 pi over 3 is 4 pi over 6, and pi over 2 is 3 pi over 6. So you subtract them and you get pi over 6, common denominator. So 25 sine of pi over 6 plus 40 is 52.5. Sine of pi over 6 is a half. Half of 25 is 12.5. 40 plus 12.5 is 52.5. So you're 65 feet high. Your friend is 52.5 feet high. Therefore, you are 12.5 feet higher than your friend in car 3. Okay. All right, page 12 brings us to number 7, and it says to find an equation of the function h that represents the difference in height between you in car 1 and your friend in car 3 as the wheel rotates through theta radians, beginning with theta equals 0 at the bottom of the wheel. All right, well, here we go. The height of car 1 after rotation through theta radians is given by y theta. Since car 3 is pi over 3 radians behind car 1, the height of car 3 after rotation through theta radians is given by y of theta minus pi over 3. Then the height difference is given by this equation. H of theta equals y theta, your car, minus y theta minus pi over 3, your friend's car. So it will equal 25 times the sine of theta minus pi over 2 plus 40 minus 25 sine theta minus pi over 3 minus pi over 2 plus 40, which will come out to be the sine, 25 times the quantity, that factored out, the 25 factored out, sine of theta minus pi over 2 minus sine of theta minus 5 pi over 6. Okay. Number 8, find an equation of the function that represents the distance in height between car 1 and car 3 with respect to time t in minutes. Let t equals 0 minutes correspond to a time when car 1 is located at the bottom of the Ferris wheel where they load. Assuming the wheel is moving at a constant speed starting at t equals 0. So car 3 is 1/6 of a turn behind car 1. 2 cars, 12 cars, 2 car difference is 1/6 of a turn. Since it takes a half a minute to make one turn, car 3 is 1/6 times a half, or 1/12 of a minute behind car 1. Then at time t, the position of car 1 is y of t, and the position of car 3 is y of t minus that 1/12. So h of t equals y of t minus y of t minus a 12th. And then we just keep going and we say that we have our amplitude, amplitude of 25 times sine 4 pi, which is our omega, times t minus an eighth, our phase shift, plus 40, our k, minus 25 sine 4 pi t minus that 1/12 minus an eighth. Well, 1/12 minus an eighth, think of this as 2 24ths and 3 24ths, totaling a negative 5 24ths. Okay, the 25 factors out, 40 minus 40 cancels, and we're left with 25 times the quantity sine 4 pi t minus an eighth minus sine 4 pi times t minus 5 over 24. Okay. Okay, page 13 brings us to number 9, and it says to use a calculator to graph the function h in exercise 8 for t equals 0 to 2. What type of function does this appear to be, and does that make sense? So I get my calculator out. I've already entered it. We'll go through it. 25 sine 4 pi. I just have x, think of that as t, minus 0.125, which is an eighth, minus the sine of 4 pi times x minus 5 over 24. Okay, so then when I graph that, let me go over and turn it on. Just wanted to show that I entered that and graph it. There it is, from negative 25 to 25 and from 0 to 2. Okay, so there it is. And what does that appear to be, and does it make sense? Okay, so the function h appears to be a periodic sinusoidal function. It makes sense that it would be periodic because the distance between the two cars would be the same each time the wheel makes a complete turn. That is, every half minute, the distance between the cars repeats. Okay, page 14 brings us to the end of lesson 12. Go to your problem set.